Welcome to our introduction to trigonometric ratios. Let's go ahead and get started with the basic trigonometric ratios. To do so, let's remember this particular mnemonic device, SOHCAHTOA. Now, this mnemonic device will help you remember the basic trigonometric ratios. For example, we have sine of theta is defined to be the opposite leg over your hypotenuse. Now notice the first letters of each one of those components: S for sine, O for opposite, and H for hypotenuse. Now cosine of theta, it's actually defined as your adjacent leg over the hypotenuse. Again, pay close attention to the initial letters for each one of those components. Here we have C for cosine, A for adjacent, and then H for hypotenuse. That's the ca here. And lastly, we have tangent. So tangent of theta, it's equal to the ratio between the opposite leg and the adjacent leg. So when dealing with this type of problems in right triangle trigonometry, you probably will be dealing with this mnemonic device often. Okay. Now let's go ahead and take a look at the example given here. Example 1, find the value of sine of theta. The first thing I always recommend you to do is identify the angle of interest. In this case, we're looking for something relating to angle A. I'm going to go ahead and locate that on my diagram here. So I have angle A, and usually what I ask you to do is circle that particular angle, because based on that we're going to label the parts in our right triangle. Now, the leg across from it will be what we refer to as the opposite leg. Always remember also that the the side across from your 90-degree angle is what we refer to as the hypotenuse. And then the remaining leg is what we refer to as the adjacent leg. Now, once you have labeled all the parts, you need to pay close attention to the original question. In this case, we're looking for sine of A. So I'm going to go ahead and write it down in here, sine of A. And I take a look at my definitions here. Sine, it's defined as the ratio between the opposite leg and the hypotenuse. So I take a look at the length for the opposite leg, in this case is 27, divided by the length of the hypotenuse, which happens to be 45. Now, the next thing that you always need to check for is to see if this particular fraction is already in simplest form. Notice that we have a greatest common factor of 9, okay? Since the greatest common factor of 27 and 45 is 9, let's go ahead and divide both numerator and denominator by 9. So let me go ahead and divide by 9 here, and I get that 27 divided by 9 is 3, 45 divided by 9 is 5. Therefore, sine of A, it's simply 3/5. Okay, so that will be my solution for this particular question. Okay. Now let's go ahead and take a look at another example. Example 2. Find the value of cosine of Z. Again, it's a good idea to write down your mnemonic device, SOHCAHTOA. And given the particular question for now, we're looking for cosine. Cosine is the ratio between your adjacent leg and your hypotenuse. So let me go ahead and write that down. Cosine of theta, it's equal to the ratio between the adjacent leg and the hypotenuse. Now, in this case, again, I will pay close attention to the angle of interest, which is Z. So let me go ahead and find angle Z here. I'm going to circle that angle. And based on that, I'm going to label the opposite leg. Here, my opposite leg happens to be segment XY. I know that the side across from the 90-degree angle is always a hypotenuse, so let me go ahead and write that down in there. And then I'm going to label my adjacent leg. Okay, which happens to be segment YZ. Now, we're looking for cosine of Z, so let me go ahead and write that down in here. Cosine of Z is the ratio between the adjacent leg and my hypotenuse. Notice my adjacent leg has a length of 36, so let me go ahead and write it in there. 36 divided by my hypotenuse, which is 39. Then I'm going to try to find the greatest common factor of 36 and 39, which in this case happens to be 3. So let me divide by the greatest common factor of 3. 36 divided by 3 happens to be 12. 39 divided by 3 happens to be 13. Therefore, cosine of Z, it's equal to 12/13. Okay. Now let's go ahead and see one more example. Example 3. Find the value of tangent of x. Again, as I said before, it's a good idea to write down your mnemonic device, so katoa, especially as you are actually starting your studies in terms of the trigonometry. And in this case, let's go ahead and take a look at what we're interested in. We're looking for tangent. So tangent of angle theta, it's equal to the ratio between the opposite leg and your adjacent leg. Now let's take a look at the angle of interest. In this case, it's x. So let me go ahead and find angle x. Here it is. Let me go ahead and circle that. Based on that, I'm going to label the parts. Okay. The side across from that angle is what we refer to as your opposite leg. Now, always the side across from your 90-degree angle is your hypotenuse, which also happens to be your longest side in a right triangle. And then here, the remaining side is what we refer to as the adjacent leg. So notice, it's very critical for that we actually label the parts here based on the angle of interest. Now let's go ahead and return to the original question. We're looking for the value for tangent of x. So let me go ahead and write this one in here. So tangent of x, is defined as the opposite leg divided by the adjacent leg. So my opposite leg here has a length of 16 units divided by the length of my adjacent leg, which has a length of 30 units. I then find the greatest common factor of 16 and 30 to simplify my fraction. So that happens to be 2. 16 divided by 2 happens to be 8. And 30 divided by 2 is 15. Therefore, tangent of x, it's equal to 8/15. So to summarize, what was the critical step here? Well, you always want to figure out what is the trigonometric ratio that you're interested in, so you can come up with your formula. You always want to pay close attention to your angle of interest, so you can circle that one and label the parts based on that particular angle. And then you just start to substitute in the values corresponding to the lengths of those legs or the hypotenuse should you need that one. Okay? Then at the end, you try to simplify that particular ratio, and that's the actual value for your trigonometric ratio. Okay? Thank you so much for watching. I wish you the best of luck in your homework. Bye-bye.